Hello, welcome to Z Talk. In this video, I wanna start a new series about automation. There are a number of great infrastructure as a code product emerging to the market as DevOps methodology prevails across industries. In this series, I will share with you my learning journey of one of the most popular infrastructure as code tool, Terraform. Terraform is an open source infrastructure as code tool created by HashiCorp, which automates and manages your infrastructure, your platform, and services that run on the platform. Terraform allows you to easily deploy and destroy infrastructure at a speed to accommodate the DevOps environment. It uses a declarative config language called HCL, HashiCorp configuration language, that you only need to define the desired state of your environment, and Terraform takes care of the rest for you. It's quite similar as Kubernetes. To get you up to speed as soon as possible with hands-on, I won't talk too much about concepts as there are tons of great videos out there on YouTube to explain what is Terraform all about in detail. However, I'd like to do a quick comparison between Terraform and another great infrastructure as code tool, Ansible. As from functionality point of view, they have a lot of similarities and overlaps, which confused me for a period of time. What use cases are good for Terraform and vice versa? Firstly, both tools are infrastructure as code. However, each has its own specialties. Terraform is good at infrastructure provisioning. On the other hand, the power of Ansible lies in managing configuration. So it's a common practice that we use Terraform to provision and orchestrate the infrastructure. And once the infrastructure is ready, Ansible comes to the picture to configure the infrastructure, deploy apps, and install or update softwares. I made an example like we have an application that is composed of three microservices, and we need to build up an infrastructure from scratch for it. Let's use Azure example. Firstly, I will spin up three VMs, configure network and firewall rules, etc. Next, as these microservices are containerized by Docker, we need to install Docker on each of these three VMs to hold the microservices. Of course, these tasks have to be done in a certain order due to the dependencies between each other. Based on this simple scenario I described, Terraform is the best option to fulfill this whole procedure. Once the infrastructure is ready, we then can go ahead, deploy the application, and install or update software by Ansible probably. And once the dev and testing are done, what's more, we can use Terraform to easily replicate the same environments for QA and production. Okay, let's quickly talk about Terraform architecture. It's really straightforward. Basically, there are three key points. So firstly, you create a Terraform configuration file to define what needs to be created. Secondly, Terraform then takes care of the rest by comparing the current state of the setup with whatever you desire in your configuration. And if it's find out the current state does not match the desired state, it will create a plan to get the environment to the desired state. And third, there are tons of providers available for infrastructure as a service, platform as a service, and software as a service to make it possible to create whatever stuff you want. This pretty much my presentation part. Let's quickly go to the demo session. In this demo, I will create multiple VMs with standard naming convention on AWS by Terraform. let's do it.
First thing first, we need to install Terraform. Just Google Terraform install and click the first link to go to the official website. For me, I'm using Mac. The easiest way will be through Homebrew. Uh, Scroll down to the install section and pick your OS flavor. And for me, I click Homebrew, and all I need to do is just issue these three commands accordingly, and I'm good to go. So once the install is done, jump to the command line and issue Terraform version to verify if the install was successful. So here I'm on the latest version, so I'm good. Next, I'm gonna create a user for Terraform on AWS and grant it necessary permission so that Terraform is gonna use that user ID to perform whatever task we assign. Uh, let's jump to the AWS, and in the search bar, type in IAM. We need to go to Identity and Access Manager to create an ID. Click Users. I'm gonna call it Terraform. For the access type, check pragmatic access. Next, we need to create a group to hold the ID and grant that group permission. So I'm gonna call this group admin, and we need to grant administrator access, which provides full access to AWS services and resources. Created the group. Next, you can add whatever tag you want. Next, review and create user. Okay, the Terraform ID was created. So just write it down, these access key ID and secret key. We're going to use this shortly in our script. Okay, all prep is done, so we can go ahead to create our first Terraform script. Here is the basic syntax of Terraform config language. Basically, a script is composed of multiple blocks. Blocks are containers for other content and usually represent the configuration of some kind of object, like a resource. Each block has the type, like resource is the block type. After block type, you can create as many as block labels to tag this block. By the way, for editing your script, I highly recommend it to use Visual Studio Code because it provides a good extension to support Terraform. Click this extension and search for Terraform and download this guy, HashiCorp Terraform. Basically, it's able to provide syntax highlighting and auto completion. Once you install the extension, we are good to create our first script for spinning up a VM on AWS following this structure. Let's exit out. And you see the configuration name in with TF means Terraform, so that Visual Studio Code knows the type of the config. I will create a resource block. So let me type in resource. You see the syntax hint already pop up. So just hit enter and the structure is automatically built up. So I'm gonna create a instance. So let's type in AWS instance. So choose the first one and give it a label. I will call it my first AWS instance. And inside of the block, I have to define a couple of arguments to specify what image I'm gonna use and the type of the instance. So I'll use AMI. AMI means Amazon Machine Image, and The other argument is instance type. So let's quickly jump back to the AWS portal to figure out what image and instance type I'm going to choose. Click EC2. And under resources, click instance running. And then click launch instance on the top. For demo purpose, I just randomly pick a image series number and in free tier eligible, like the first one. Copy that and paste it to your editor, AMI. And move back to your browser and click select. And next step, for the instance type, I'm also going to choose free tier T2 micro and paste it to instance type. And next, I'm going to create another block to provide your account information, basically the user access key, etc. I created at the beginning. So this block type will be provider, and this is AWS. And inside of this block, I'm going to provide a argument as access key and secret key and region. Let's start with region. So go back to the portal. I choose to deploy VM under north call, so US West 1. So back to your editor, type in US West 1, and now go back to IAM to grab your access key info and click user, Terraform, and security credentials. Okay, here we are. By the way, for any reason, if you forget where did you store your private key, so what you can do is firstly make the existing access key inactive by clicking make inactive. Click the active, and then you can delete the existing key. Delete. Now create a new one. So copy the access key to your editor, and then secret key, and save it. Now we're good to apply this configuration by Terraform, and let's verify if the VM is deployed as expected. Okay, I'm on my terminal now. So just remember, every time after you create a new config file or a folder, what you need to do first is to initialize by issuing Terraform init. So once Terraform has been successfully initialized, the next command you will do is Terraform plan. So basically, it's gonna do a config check. Let's take the Terraform plan. And if you're familiar with Kubernetes, it's pretty much like dry run. So if everything works as expected, you can see what's gonna happen here. See, an instance will be created by using this image, and the instance type is T2. Basically, that's what we define in our config file, right? And looks good. Let's apply by type Terraform apply and typing yes to approve. Now it's time Terraform deploying the VM to the AKS. AWS. It will take a little bit of time. Okay, it's pretty quick. Looks the VM has been created. Let's move to the portal and double verify. Refresh. Yeah, here we are. There's a new instance I created and it's up and running. Cool. So let's say once the instance ready, we play with the instance and we're done with it. Now we can use Terraform to destroy as easy as how we created. So by issuing Terraform destroy and type yes to approve. Okay, now destroy complete. The instance should be gone. Let's verify. Just refresh. Boom, that instance is gone. So good. That's pretty much it.
Okay, what if I want to spin up multiple instances at a time and I want to give each instance a meaningful name following certain naming convention? Okay, that can be done by adding two additional arguments inside of resource block. The first one will be count. Let's say I want to spin up 3 instances at a time, and the next one will be a tag. So see, here is the key value pair. So the name will be name and value. Let's come up with a naming convention. Say demo instance. To make these value dynamic, I will create a variable by $, curly braces, and count index. Okay, let's test it out, what it can do. I'm jumping to my terminal and I will issue Terraform plan to verify if there was any syntax issue in my script. Okay, looks good. See, there will be 3 instances created. So let's do Terraform apply. And prove by typing yes. And let's jump to the AWS portal to verify. Do a refresh. Okay, seems it's done. Let's do another refresh. Okay, here you are. So there were 3 instances being created, and see the name it is following the standard like demo instance 0, 1, 2. Okay, looks good. Let's wipe them out by Terraform destroy. This script has been working so far, but is still far away from perfect. As you can see, it contains plain text sensitive data like secret keys as highlighted. It will be a big security violation. What I can do, I can break the config into separate files to store the sensitive data and replace each value with a variable. So when I share the config out, I can just upload the config file with variables and keep the real sensitive value in local. Firstly, I will create a config file to define variables to replace the sensitive keys. I will call it variables.terraform. Okay, inside this file, I'm gonna create a couple of variables. You see the first three gonna be for access key, secret key, and region. And I also introduced another variable called AMIS, and you can see the type of this variable is a map. So inside of this map, I basically give some default values of basically the images I get default images I'm going to use per region. So basically this file is to define some standard images that I'm going to use per region. So I'm going to test it out with different regions shortly in the demo. All right. Okay. Okay, I defined the variables, but I haven't given the values yet. So I will have to create another file to store the value. So I create another file called Terraform variables. Uh, so before I jump to that file, remember I create these three variables. Name is AWS underscore access key, secret key, region. Okay, let's jump to the values file. So here, those were the variables I created in the other file, and I assigned the real keys after it. Basically, these files are gonna be the one that store on my local only. So, for example, if we plan to share this config out to GitHub, we can config to avoid sending these files to GitHub repo. Okay, what else? Let me go back to the original create instance, the config file. So I'm gonna take these provider block off of these config file to another file I called a provider for basically it's just for better code management. I will take these part out and back to the provider. All I did just to replace the value to the variables that I defined, right? Okay, so last but not least, I'm gonna update it a little bit in the create instance file. So because this time we're gonna use only one instance for testing, so I'm gonna take these count equals 3 out, and also for tags, I'm gonna remove this variable count index variable out. So for this instance, I'm gonna call it demo instance only. Okay, and the most important thing, so for the AMI argument, I'm gonna replace this constant variable with a lookup function. I'm gonna look up these two variables. Firstly, gonna be AMIS, and the second gonna be region, AWS region. Okay, it's pretty much it. Let's make sure all files have been saved, and we can move to the terminal to test it out. Okay, before I jump to my terminal, let's verify the code one more time. So in the uh, Terraform Terraform variables file, so basically this was the file to store the real value of access key, secret key, and region, right? So here I'm using, for the region, I'm using US West 1. So let's go back to the variables files. So for these AMIS map for the US West 1, you're going to use the images end with 32F9. So, okay, let's see if it works as expected. Let's jump to the terminal, and just remember every time there were new files or directory being created, you have to rerun that Terraform init command to make sure it's being initialized again. So let's do Terraform init. Okay, so the initialization was done, so we're good to run Terraform plan for the dry run. Okay, you can see there will be a instance added. Let's scroll up a little bit to verify the detail. Okay, so for the AMI, so that's the images 32 F9 images. That's exactly what we wanted, right? So let's change the value to another region and see the difference. So for another region, let's get back to the editor, and I will pick another one with different image. Let's say, how about US West 2? So just remember the image will be 63F. So back to the values file. So I changed the US West 1 to West 2. Okay, save it and go back to the terminal and run that Terraform plan for dry run one more time. Let's go. Okay, let's scroll up for detail. Okay, cool. So this time the image will be 63F. Cool. That's pretty much I want to share for this session. Thanks. Thank you very much for watching ZTalk. See you next time.